Okay, we're in the final section of 7.1 and we'll be looking at troubleshooting inductors. There are only three possible defects probable with an inductor. The first is an open in the windings, and that's depicted right there actually, a short between windings, and a short to ground or another component. And here we have an overview of all the things that can happen to an inductor, and we show the defect here, and then what we would expect to see with an ohmmeter. Okay, first of all, if there is no defect, and we connected our ohmmeter into the circuit, we would measure the resistance of the coil winding. Now the thing is that this is typically very low, and we're talking about with an ohmmeter you're only going to be measuring maybe 2 to 3 ohms, so it's a very small value because remember you're just looking at a piece of wire. Okay, the next one would be open windings, and in this case here we have an open, and in this case the resistance would be infinite. We would have infinite resistance here, so if you read resistance, infinite resistance in a coil, you have an open. Then there is the potential of shorted turns. Now this would be the scenario where, and they usually be shown closer, but this one is maybe shorted to this one. And so in that case, we would have a lower than normal resistance. Now the thing is, with an ohmmeter, this is really kind of hard to see because the normal reading is extremely small, so the shorter turns is often hard to pick up with an ohmmeter. And then coil to core short, and that's the case where you have a coil, the coil is shorted to the core material, which should not be. And here, let's see, a common fault with inductors is a shorted coil, and that's the one we just mentioned. Usually, it is the result of insulation that has melted due to overheating. It is often very hard to detect the problem with an ohmmeter because a good reading may be only 2 to 3 ohms. The failed reading may only vary by a fractional portion of an ohm. And there are meters which can test for inductance. In fact, your textbook has a picture of an inductance meter, and in this type of situation, that's probably what you would need. And in this graphic here, you see this is a cutaway of an inductor, and all of these wires, there's insulation wrapped around there, and you can see here that 2 wires, the insulation is melted and they are actually shorted together, and this would cause a failure in an inductor. Okay, this is a depiction here of how to test for the last fault we mentioned was the short between the core and the coil. And so in this case we have our ohmmeter connected, and this is to the core material, and the other end of the ohmmeter is connected to the actual coil itself. Now, under normal circumstances, there should be no connection, and so the normal resistance here would be infinite. We would expect to have an infinite reading in this situation. Now, in this situation here, it's the same configuration, only now we're reading 0 resistance. Now, in this case, 0 resistance indicates that there is a short between the windings and the core, and this indicates a bad inductor. Okay, so this has been a brief lesson looking at procedures you might use to troubleshoot an inductor.